Solar charge control devices controls the energy coming from solar panels. It adjusts the current and the voltage, then send it to batteries. Charge control device prevents overcharge and over-discharge to protect the system. Each solar energy systems requires a charge control device. Charge control devices divided into two as PWM and Mppt. Two types of solar charge controller. The two types of charge controllers most commonly used in today's solar power systems are pulse width modulation and maximum power point tracking. Both adjust charging rates depending on the battery's charge level to allow charging closer to the battery's maximum capacity, as well as monitor battery temperature to prevent overheating. What is PWM charge controller? PWM stands for Pulse Width Modulation. PWM charge control devices can be explained as an electrical switch between batteries. The switch can be quickly switch on and switch off. Therefore, desired voltage can be obtained to charge the batteries. The charge current will be slowly decreased as the battery is charged. What is Mppt charge controller? Mppt stands for maximum power point tracking. Mppt is a technique to observe and regulates the energy going from solar panel to the batteries. Solar panels show changeable outputs according to weather conditions. Mppt charge control devices can match the solar panel voltage with battery voltage to maximize the charge efficiency. Difference between two controller. The main difference between PWM and Mppt charge control devices is that the Mppt devices are more efficient. Mppt charge control devices have 30% more efficient in charge efficiency according to PWM type. Panel voltage and battery voltage should be matched in PWM systems. In Mppt systems, the panel series are allowed to have higher voltage than batteries. This means more flexibility for system growth. On the other hand, Mppt controllers are more expensive than PWM controllers. Because of that, in small systems where the efficiency is not critical, are still using PWM charge controller. Comparison of Mppt and PWM. If maximizing charging capacity were the only factor considered when specifying a solar controller, everyone would use a Mppt controller. But the two technologies are different, each with its own advantages. The decision depends on site conditions, system components, size of array and load, and finally the cost for a particular solar power system. Effects of temperatures. An Mppt controller is better suited for colder conditions. As solar module operating temperature goes down, the VMP1 increases. That's because the voltage of the solar panels operating at their peak power point at standard testing conditions is about 17 V while the battery voltage is about 13.5 V. The Mppt controller is able to capture the excess module voltage to charge the batteries. As a result, a Mppt controller in cool conditions can produce up to 20 to 25% more charging than a PWM controller. Solar system size relation. Low power systems are better suited to a PWM controller because a PWM controller operates at a relatively constant harvesting efficiency regardless of the size of the array. A PWM controller is less expensive than a Mppt, so is a more economical choice for a small system. A Mppt controller is much less efficient in low power applications. Systems 170W or higher tickle the Mppt's sweet spot. Charge controller cost. Mppt controllers are typically more expensive than PWMs but are more efficient under certain conditions, so they can produce more power with the same number of solar modules than a PWM controller. One must then analyze the site to verify that the Mppт can indeed perform more efficiently when used in that system's given set of conditions.